Halo, tes. Semoga masuk ya. Ini kita streaming hari ini. Update terbaru buat komponen. Sudah dikirim launchpad-nya, jadi kita bisa melanjutkan belajar dulu track package. Masih di US ya paketnya. US 19, cukup lama. Seharusnya kita ngelanjutin buat lab alias praktikum, tapi komponennya belum datang. Terus visual. Ini gradernya nggak bisa di-download, entah kenapa ya. Harusnya bisa di-download tapi nggak bisa. Jadi kita praktikum mandiri saja, nggak ada gradingnya. Texas. Grader yang ada di download. Oke, skip dulu. Di praktikum pertama, basic input output dari mikrofon analog, accelerator, light sensor, square C, button. Hari ini berapa ya? Boson CCNA prepare. Jadi aku baru suka belajar computer network. However, we need some certification to prove that we are learning and gaining skills. Like SimMax. Nah, ini aku dapat dari YouTube-nya. CCNA 200-301 experience sharing. Ya, Jeremy's IT Lab. Recommended-nya itu. Kita lihat CCNA dulu. 3 years research. Few exam topics. Let's just say Taiwan. Okay, and let's receive sign up. Yep. Network fundamentals. Routers we know already. Layer 3 switch. Nggak tahu layer 3 switches. Controller, endpoint, server, PoE, power over Ethernet. Nggak tahu. TCP, UDP ya tahu. Unicast, multicast. Describe wireless principle. Ini 1611 SSID, RF encryption, virtualization, switching, frame flooding, network access, VLAN. Oke, banyak yang aku nggak tahu ya ini. IP service. Bentar guys, mau ngechat sama dulu. CCNA 201 course. Kita belajar course aja ya. Kayaknya bagus.
Welcome to my complete CCNA, Cisco Certified Network Associate course. This is Jeremy's IT Lab. Since this is the first video, allow me to introduce the course. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. There will be lecture videos covering every topic on Cisco's official exam topics list, practice quizzes covering the material in each lecture, flashcards to help you review and remember what you learned, practice labs using Cisco's network simulation software Packet Tracer, and at the end, multiple practice exams to get you ready for the real thing. Although this course will be based on Cisco's official exam topics list, I also want to give you extra information to improve your understanding of networks in general. That additional context should also help you understand the exam topics. Because this is the first video in the series, I want to talk about who this course is for. This course is for anyone who wants to pass the CCNA 200-301 exam. At the time of recording this video, this is a new exam that isn't released yet, but will be coming on February 24th, 2020. Although a lot of the information will overlap with the old CCNA, the course will be based on the exam topics for the 200-301 exam. This course is for anyone who wants to learn about computer networking. You don't have valuable I will cover and ado, don't need to know get started. Be the foundation, which we will build upon each of these symbols and more. Foundational knowledge. Let's ask our friends at which allows network nodes. This is but is also you probably software finance. If you know if you're on top, get into it. Each of these node type server. Okay, so in a network. So with a action once nodes to and clients will these definition if you running all is what see right even where okay, since server is part of the definition of a client, when you think of Dell service in DAT, a client is a device that accesses a service made of. So remember, let's look at the simple network is the client. Which is the client and which is the server? Well, PC1 is the one requesting the service, requesting the image. Is your computer server? The answer. Internet is a very passive diagram. Your computer sends a request to the YouTube the data all at once. iPhones. So you ask, and his phone responds to the server. Phone on is a device that accesses a service. In some cities, you have a better idea of what a client part of enterprise. I also couldn't fuse our servers directly to each other. You aggregate the connections to a device called a switch. As you can see, the two PC switches have a catalyst switch. As you can see, lots of interfaces or ports to plug your PCs or servers into. Switches are used to forward traffic within a LAN, a local area network. PC1 and PC2, as well as other devices plugged into switch 1, such as a network printer or another PC, all reside on the same local area network. The same goes for any devices connected to switch 2 in the Tokyo branch. So, we have one LAN on the left and one LAN on the right. The hosts within each LAN can send data to each other, for example, PC1 to PC2. However, these switches cannot connect directly to the internet and send data between the switches. Here on the left is the same Cisco switch from the last slide. It's a Catalyst 9200. Catalyst switches are Cisco's enterprise-grade switches, used by many enterprises to connect their LANs. Now let's review some characteristics of switches. Usually 24 or more, a local area network, within the small office connectivity between LANs or over the internet. That to connect the routers to the internet. When end hosts in the New York branch LAN want to communicate with end hosts in the Tokyo branch LAN, they will send the data to the branch over the internet. Let's talk the characteristics of routers. These are a few examples of Cisco routers you might find in use in an enterprise network. The ISR 1000 and ISR 4000 have their network interfaces on the back, but if you look at the ISR 900, you can probably notice a difference between a router and a switch. Let's bring up one of the switches we looked at before. Compared to this Catalyst 9200 series switch, the ISR 900 router has relatively few network interfaces. That's one characteristic of routers compared to switches. Routers have fewer network interfaces than switches. Also, remember that switches are used to forward data within a LAN. Routers do the opposite. Routers are used to provide connectivity between LANs, and because of that, routers are therefore used to send data over the internet. Here's our network once again, but this time there's a difference. There is an attacker somewhere in the internet with an arsenal of many, although is, that control network traffic entering and exiting your network. Firewalls like Firewall 2 and servers in traffic should be allowed and which should be denied. New York branch, the return if the attack on to PC1 should be to permit the traffic through. All should block it. So let's look at a couple of Cisco's firewalls. At the top here are two examples of Cisco firewalls. On the left is an ASA 5500X series firewall. The ASA, or Adaptive Security Appliance, is Cisco's classic firewall. Although the ASA is their classic firewall, modern ASAs include modern features of so-called.
Kenapa firewall harus jadi device tersendiri dipisah dengan router ya? Performance rather than performance.
Called next-generation firewalls, including things like IPS, or Intrusion Prevention System. You'll hear a lot more about that in the security section of this course. On the right is a Firepower 2100 series firewall. This is a next generation firewall as well. Okay, let's review some characteristics of firewalls. Firewalls monitor and control network traffic based on configured rules, not. Meaning the firewalls are known as next generation firewalls when they include more modern and advanced filtering capabilities. Both of these Cisco firewalls are considered next generation firewalls. Now, I have one more thing to look at regarding firewalls. What about the firewall on your computer? Let's take a brief look. The two firewalls we looked at in the previous slide are network firewalls. Network firewalls are hardware devices that filter traffic between networks. These are the kind of firewall we will focus on in this course, as it is a networking course. However, there are also host-based firewalls. Host-based firewalls are software applications that filter traffic entering and exiting a host machine, like a PC. Your PC almost certainly has a software firewall installed, as it should. Network nodes? Keep in mind, there are other kinds of network devices, which will help improve your understanding to review the lecture's material where. As I will upload CCNA practice videos.
What's it like to learn math on Brilliant.org? Brilliant gets you hands-on to help you learn by doing.
In some cases, there are multiple answers that could possibly be correct, but there will always be one best choice. Cisco exams tend to have lots of questions like that, so hopefully some of these will be able to test you in a similar manner. This first video's quiz questions, however, shouldn't be too difficult. Your company wants to purchase some network hardware to
computer network. Okay.
to which they can connect the 30 PCs in your department. Which type of network device is appropriate?
Switch.
A. A router.
Switch.
Pause the video to this. C. A switch. A router, like the Cisco ISR 900 series router, is designed for forwarding traffic between networks, not to connect hosts to Cisco ASA. It is not designed to a firewalking device to which a switch. Okay, let's go using AirDrop.
What was
You received a video file from your friend's Apple iPhone using AirDrop. What was it?
server?
Access is it can help. Your friend's phone provided this question. A server. What is your computer or smartphone functioning as while you watch this video? A client. Receiving a service. C. A client. Hosts in a net is received answer. To connect its separate networks together. What kind of network device is appropriate? LAN or all can connect. The answer is D. A router. The purpose is LAN is incorrect. So D, a router, is that wants to upgrade its old network firewall that has been in use for several years to one that provides more advanced functions. B, a top layer firewall. The answer is based firewall is next generation software that runs host-based firewalls. Firewalls correct. Features support.
Oh, nice.
I also accept donations via cryptocurrency or Patreon via the links.
Your employees work from anywhere, and so should your security. Cisco Umbrella.
Welcome to Jeremy's IT Lab. This is a complete course for the CCNA, Cisco Certified Network Associate. In this video, we will look at one of the supplemental resources I provide for this course, Anki flashcards. For most lecture videos of the course, I will provide a deck of flashcards that you can open in the Anki app. Anki is an example of SRS, spaced repetition software. Ankis don't have to use the apps.anki their documentation. Let's click on Linux, as well as iPhone and Android.
Download Anki. Download Ubuntu Linux. What's the difference? Qt. Let's see.
I use Windows, so I've downloaded and installed. The developer uses the sellers. Say web browser cards anyway, and open the app. It will look like this, available for your platform, and install it like any other app. Once you install it and open the app, it will look Anki available. It's limited, but good enough for just reviewing flashcards. Anyway, download the latest version of Anki available for your platform and install it like any other app. Once you install it and open the app, it will look like...
Okay, Qt6. How to install? Okay, let's bring up our terminal. cd download sudo apps update. Okay, and then copy this and paste y. Okay, tar xaf Anki cd Anki sudo install.sh. Okay, install complete. Then I can close this and Anki.
this. We could spend a lot of time looking at the various functionalities in this course. There are other ways you can open the app. You will see this default deck here.
Anki. English. Yes.
This deck will be here until you create or import another deck. So let's create a deck by clicking the Create Deck button down here. I'll name it CCNA and click OK. Notice the CCNA deck has now replaced the default deck. We are going to use this CCNA deck as a parent deck and import the decks for each day of my CCNA course as subdecks of this one. Now, how can you get the flashcards for my course? Let's go to the first video of the course, Day 1, Network Devices. The link to get both the Anki flashcards and the Packet Tracer lab files is in the top line of the description of the videos, where it says free CCNA flashcards and Packet Tracer lab files for the course. The link is jitl.jp/ccna-files. If you click on that link, you will be redirected to this page. If you want, you can just type in this URL directly, sendfox.com/jeremysjoin. What should happen after that is you will get an email to confirm your address, and after you confirm your email address, you will get the email with the links for the flash jeremysitlab.com. 10 minutes. I often get emails from people saying they couldn't receive the flashcards. Subscribe from the mailing list. Date. The files are all in a Google Drive and labeled by the day of the course. Day 1 flashcards, day to sign up multiple times. Each email. For this demonstration, I've downloaded the flashcards for Day 1 and Day 2. Here they are in the folder. And click to import them. For this demonstration, I've downloaded the flashcards for Day 1 and Day 2. Here they are in the folder.
Download Anki and Anki delete. Send us. Delete. Go delete. Delete this one. No. Version. Start this. Delete.
To import them into Anki, you can
minutes.
then simply click on the files. I'll import Day 1 by clicking on it, and click Close on this notification, and then do the same for Day 2. Now both decks are imported into Anki. Notice next to each deck there is a 20, indicating that there are 20 new flashcards in these decks to learn today. Here's my first recommendation. Increase the maximum number of daily new cards and reviews. To do that, click the gear icon for either of the decks. Notice that the default settings for new cards per day is 20, and maximum reviews per day is 200. I don't want Anki limiting my new cards or reviews, so I'll just increase these to 999 and 9999 and click on Save. Now notice that the Day 1 deck has 22 new cards, and the Day 2 deck has 57. Those are the actual number of cards in each deck. Before, the number of new cards Anki would show was limited by that setting. Of course, you don't have to increase the limits, that's just what I do. My recommendation is to make the flashcard decks for each day of the course sub-decks of this CCNA deck we made earlier. To do that, click on the deck name and drag and drop it onto the CCNA deck. I'll do it for both decks. Now the CCNA deck has 79 new cards ready for us to learn. But if I click on the plus icon next to the deck name, I can see the individual sub-decks. So you can click on Killer Deck. For this demonstration, I'll just show the Day 1 cards. Flashcard we are shown. The ellipses in square brackets is the information you have to remember. That's the format I use for my flashcards. So think of the answer, and then to check if you're correct, click on Show Answer down here. Now there are a few options. If you got the answer wrong, you can click Again. And note that it says less than 1 minute above. That means if you got the answer wrong, you can click Again. And note that it says less than 1 minute above. That means Anki will show you the card again within 1 minute, so you can try again to get the right answer. If you got the right answer, but it was hard, it took some time to remember, you can click on Hard. In that case, it will show you the card again within 6 minutes. Good is the normal option. It will show the card again within 10 minutes. And if the card is easy, you can click on that, and it will show the card again in 4 days. Personally, I recommend using only the Again and Good buttons. If you answered correctly, click Good. If you didn't, click Again. Nice and simple. I'll click on Good, and now that's our first card done for now.
And we're back in third quarter planning. Adams is quarterbacking this project, and
Notice above the Show Answer button, the blue number is now 21. Those are the new cards, and now there is a red 1. That card has just moved from New to Learning. In Anki, new cards must be reviewed twice in the first day. The first time they will be included in the blue number, meaning New. The second time, they will be included in the red, meaning Review, meaning Learning. After that, when Anki shows us that card in the future, it will be in the green category, meaning Review. Let me demonstrate. I'll just use the spacebar to go through these new cards. If you hit the spacebar, the option in blue will be selected, which is Good in this case. And each time I select Good on one of the new cards, it is moved over to the Learning category. After we get back to the first card and hit Show Answer again, notice that this time, if I select Good, the interval is increased to 1 day. That means tomorrow, Anki will show me the card again. If I answer correctly again tomorrow, that interval will increase, maybe to 3 days. And if I answer correctly that time, it'll increase again, for example, maybe to 5 or 6 days after that. That's the power of SRS apps like Anki. As you correctly answer each flashcard, that flashcard's interval increases to help that information stay in your long-term memory. I'll just use the spacebar again to go through these cards. And then, this deck will be done for today. Tomorrow, Anki will show me all of these cards again, because they all have a review interval of 1 day currently. I'll click on Decks to return to the menu again. So, now next to the Day 1 deck, there are 0 new cards. Tomorrow, Anki will show me those cards again for review. They will appear under the Do column. Before wrapping up, let me give a bit. Anki will show me those cards again for review. They will appear under the Do column. Before wrapping up, let me give a bit of advice. First is not to add more than 1 deck at a time. For this demonstration, I added both Day 1 and Day 2, but I'm only learning the Day 1 cards. If you add too many new cards each day, the number of reviews Anki will give you every day will accumulate and take a lot of time to review. And make sure to do the reviews Anki schedules for you every day, because if you miss a day or two, that will also cause the scheduled reviews to accumulate, and it will be hard to catch up. My personal recommendation is to add each flashcard deck after you have studied that particular day's lecture video. After you've studied Day 1, add the Day 1 deck. After you've studied Day 2, add the Day 2 deck, etc. Then, do the scheduled reviews every day by just clicking on the parent CCNA deck, rather than each individual subdeck. But, as I said before, these are just my recommendations. You are free to use Anki as you wish. In this video, I only show the basics you need to review my flashcards, but you can do a lot more in Anki, such as creating your own flashcards. I recommend spending some time getting familiar with Anki and its capabilities. Flashcards, you can choose exactly what tool, not just for the CCNA, but for anything. By making and reviewing effective flashcards, you can choose exactly what information you will remember, rather than leaving it up to chance what information your brain will remember and what information it will forget. Rather than leaving it up to chance what information your brain will remember and what information it will forget. Okay, that was a quick introduction to Anki. They are very helpful for remembering. Use it, check out Google. Before finishing this video,
Yep. Here are. What time is it? Jam 4. Just jam. "63 days. Okay. Let me think.
Yo, let me thank my JCNP level channel members. Reader, Fullerson, Watts, Mick Mustatme, another graders.
Okay, let's review it. Lab. Let's just download everything. Nope. Okay, open it and cut, move it to document, learning, new folder, CCNA, paste, and then unzip CCNA. Oh, sorry. Yep. And delete. Open this. Day 1 lab. Day 1 flashcard. Move it here. Import. Close. Move it inside and put option new cards per day 999 9999. Save. Let's have 3 days right now. Import, close, and then OSI import, close. Right, where's my date? Put it inside, put it inside. 120 questions, not bad. Let's review day 1. Study now. Host space. Good. Server. Good. Within some switch. Good. Firewall. Good. Firewall is computer. Next generation. Good. Is a device that access a service client. Good. Local area network. Good. Is used to send data over the internet router. Good. Good. Computer network is the one which allow host or computer nodes are and host and host or endpoint. Client. Oh, okay. Server is and host. Oh, okay. Okay. Switch. The data monitor is on configured rule firewall. Good. Event provides function or service for client server. What kind of network device is Cisco ASA is firewall? No, router. Oh, firewall. It's hard. Has many network interface for end host to connect to. Switch. Router have few, little. Router. Good. Can be both client and server? No. Yes. Hard. ISR. Anything. ISR is a router. Good. Firepower. Firewall. No. Yeah, firewall. Catalyst switch. Client. Good. server or client, which allow nodes. ASA is firewall. Yes. This uses a router. What does LAN stand for? Local area network. What does simulation switch? Firewall. Host base is a device that accesses a service made by a fellow client. Next generation firewall. Switch. Server. Router. ISR router. Router has a fewer provides function or service for client server. Catalyst switch. Firepower firewall. ASA firewall. Which allow nodes. Yes. Many and host to connect to. Many network interface switch. Server or client. This one is a client. Good. Let's see if I finish this deck. Now, if you wish to study yourself, you can custom study feature. Cancel. Let's go.
名人新手舰长挑战赛，在一场战斗中完成888点或是16888点伤害。
Welcome to Jeremy's IT Lab. This is a complete course for the CCNA, Cisco Certified Network Associate. In this video, we will look at an essential part of the course, the labs in Cisco Packet Tracer. First of all, what is a lab? In the world of IT, doing labs or labbing refers to hands-on practice with the technology you're studying. Since you're studying for the CCNA, labbing means practicing configuring Cisco routers and switches. There are a few options for CCNA labs. One is to buy actual physical Cisco hardware, real Cisco routers and switches. However, that can be expensive and isn't very convenient. Fortunately, Cisco has an amazing tool called Packet Tracer, which lets you set up simulated networks on your computer. We will be using Packet Tracer for the labs in this course. Packet Tracer is free, quick and easy to set up, and lets you create simulated network labs without having to buy any hardware. The network devices in Packet Tracer aren't real network devices. It's just software designed to simulate network devices, so you can practice configuring them. In this video, we won't actually configure any routers and switches, since we haven't learned any configurations yet in the course. Instead, we'll just get familiar with the Packet Tracer user interface and how to build simple networks. First of all, how can you download Cisco Packet Tracer? You can download it for free from Cisco on this page. Note that I've created a simple redirect link that will take you to this page. It is jitl.jp/packet-tracer. Follow that link and it will take you here. However, first you will probably see this login page. You need a Cisco account to download Packet Tracer, so you can log in here. Or if you don't have an account yet, click on Sign Up at the bottom of this page to create one. Once you have created an account and logged in, my link jitl.jp/packet-tracer will allow you to see this page. First, let me point out that Cisco's learning platform Net Academy has a few courses about how to use Packet Tracer. If you really want to learn how to master Packet Tracer,
Taiwan, 999, months of birth 9. What? Yes. That's my name. Please wait. Authenticating. 11/22 March. Okay. No way. I'm at state. Okay, it's Taiwan. What? Okay, whatever. None. Create account. Okay, thank you, Net Academy. Now I just click the Packet Tracer.
itself, Netcache Packet-Tracer, will allow you to see this page. First, let me point out that Cisco's learning platform NetAcademy has a few courses about how to use Packet-Tracer. If you really want to learn how to master Packet-Tracer itself, you can take these courses like Getting Started with Cisco Packet-Tracer, a short 2-hour course, or the one below it, Exploring Networking with Cisco Packet-Tracer. In my course, we won't look at all of the different functionalities of Packet-Tracer, just the ones we need to do the labs in my course. So if you're interested in learning more about Packet-Tracer, you can take these free courses from Cisco. Anyway, scroll down, and this is where you can download Packet-Tracer itself. It is available
Ubuntu is okay.
for Windows in 64-bit and 32-bit versions, as well as Ubuntu and Mac OS. Download the appropriate version for your computer and install it like any other program. For my course, download the latest version, which is 8.2 at the time I'm making this video.
It's quite T CD download. Okay. Let's wait for.
If you have an old version, you might not be able to run some of the labs. Old versions of Packet-Tracer can't open lab files made in newer versions of Packet-Tracer. However, new versions of Packet-Tracer can open lab files made in older versions of Packet-Tracer. So if you have the latest version, you should be able to open all of the lab files. Now, how can you get the lab files I provide for my course? It's the same as the Anki flashcards. If you got the link for the flashcards, the lab files are in that same Google Drive, so there's no need to follow these steps again. But I'll demonstrate once more. The lab files are in that same Google Drive, so there's no need to follow these steps again. But I'll demonstrate once more just in case. Here is the first lesson of the course again. In the top line of the description, there is this link: free CCNA flashcards and Packet-Tracer labs for the course. And the link is jitl.jp/ccna-files. Click on that link, and you will be redirected here to sendfox.com/jeremysitlab. Enter your first name and email here, and then click join, and then you should get the files in your email. If there are any issues, I'll get a bit of Packet-Tracer, and let's get it. Okay, once you've got my lab files,
Packet-Tracer, okay. Why it's so long? Done. Okay. Sudo apt install. And let's transfer. Wait, what? Where can I get this? Cisco. Cisco Packet-Tracer Y. Okay. Yes. EULICE and user license agreement. Yep. Okay.
open the lab file labeled Day 1 Lab in Packet-Tracer, and let's get started.
Day 1 Packet-Tracer. Open with Fuel application Packet-Tracer. PRS. Cisco. Would you like to run multi-user when application start? Yes. Thank you. Give me login. NetAcademy. Login with Google. gmail.com. What is this?
Once again.
Rested. Why is so hard? What is this? Let's take oh, yep, verification. Yes, it's me. Okay, good. Now file, open, APMA, document, learning, CCNA, day 1, open. Okay.
Note that when you install Packet Tracer and then open it, you will have to log into your Cisco account again. After that, you should see my lab file like this if you opened Packet Tracer by clicking on the lab file. If not, just go to the File menu and click Open to open my lab file. In my lab files, the lab instructions will usually be on the left File menu. You should see my lab file like this. Packet Tracer and then open it. You will have to log into Tracer and account again. After that, you should see my lab file like this if you opened Packet Tracer by clicking on the lab file. If not, just go to the File menu, bottom of the screen, and then there will be some devices I've already placed in the network. In this first lab, there is just one router, which I have named the Internet. Then, the lab instructions tell us to place the other devices to make a network. Note that throughout the course, I expect that you will be using my pre-made lab files to do your labs. You are free to make the labs yourself from scratch without downloading my lab files, but that won't work for all of my labs. Some labs in the course require troubleshooting. In those labs, I purposefully made some configuration mistakes, so it's your job to find those mistakes and fix them. Okay, before we go through the lab instructions for this first lab, I want to show you the Packet Tracer Preferences menu. Go to Options in the top menu, and then Preferences. In this first tab, the Interface tab, you can select things like whether or not device model labels are shown. I usually have this off, but if I turn it on, notice that above the Internet, 2911 appears. That is the model name of this router. It's a Cisco 2911 router. I just named it the Internet to represent the Internet. I prefer to have device model labels off, so I'll remove this. If you don't want to show the device name, you could uncheck this here too, but I think it's best to leave the names on. Anyway, feel free to check out some of these other settings if you want. I just want to point out one more tab, that is the Font tab. Here you can change the font sizes in Packet Tracer. For example, all of the menu font sizes, or the font size in the device's command line interface. To make it easier to see in the videos, I set the font sizes fairly large, but feel free to set whatever size you prefer. You can also change the font colors. For example, if you want to feel like you're in the Matrix, change the Router iOS text to green, and the Router iOS background to black. Then hit Apply and Exit. Then click on the Internet router and go to the CLI tab. And hey, now you're officially a hacker. CLI stands for Command Line Interface, by the way. This is how we are going to be configuring routers and switches in the course. Anyway, I'll exit from here, and let's actually do this first lab, which involves recreating the network displayed at 16 minutes and 40 seconds of the Day 1 lecture video about network devices. Here's that network. In the middle, there is the Internet. In this lab, I'm just using a router to represent the Internet. Then there is the New York branch on the left with some PCs, a switch, a router, and a firewall. And in the Tokyo branch, there are 2 servers, a switch, a firewall, and a router. Also, somewhere over the Internet, there is an attacker. Okay, so let's recreate that network. For the routers, the instructions say to use Cisco 2911 routers, the same kind of router I used for the Internet. To place a device in Packet Tracer, go to the bottom left here, and click on this icon for network devices, and then routers. Then you can see a selection of router models. Let's select the 2911, and place 2 of them in the network. This is what a Cisco ISR 2911 router looks like, by the way. ISR is a line of Cisco routers, and 2911 is a particular model in that line. ISR is a line of Cisco routers, and 2911 is a particular model in that line. Okay, next let's go to the Switches menu here, and place 2 2960 switches in the network. Here's a photo of a Cisco Catalyst 2960 switch, by the way. Catalyst is the name of a line of Cisco switch models, and 2960 is one model within that line. Okay, next we'll place the 2 firewalls by going to the Firewall menu and placing 2 5505 firewalls. Note
Where is the firewall menu? Security.
that in the network diagram in the Day 1 lecture video menu and placing 2 within that line. Okay, next we'll place the 2 firewalls by going to the Firewall menu and placing 2 5505 firewalls.
55.
Note that in the network diagram in the Day 1 lecture video, the New York branch firewall is between the router and the Internet, and the Tokyo branch firewall is between the router and the switch. Depending on the network design, you might find the firewall placed in either position. This is a photo of a Cisco ASA 5505 firewall. ASA is a series of firewalls made by Cisco, and 5505 is a particular model within the ASA line. Okay, now let's place the end devices like PCs and servers. Go to the End Devices menu, and here in the End Devices tab, we can find PCs, servers, etc. So place 2 PCs in the New York branch, and 2 servers in the Tokyo branch. Then, to represent the attacker in the diagram, place a laptop. Okay, now all of the devices are placed. This isn't in the lab instructions, but let's rename them to match the diagram in the lecture video. To rename a device, just click on the device name. PC1 already has the correct name, so I'll start on PC2, then Switch 1, then R1, then Firewall 1, then R2, then Firewall 2, then Switch 2, then Server 1, then Server 2,
W2 SRV1 SRV2.
and finally the attacker. Okay, now we've placed and named all of the devices. To connect devices in Packet Tracer, click on this lightning bolt icon here. Now, in the next video of the course, we will study different types of cables used to connect devices together in a network. So for this video, we will just let Packet Tracer pick the cables for us by clicking this lightning bolt which says automatically choose connection type. So I'll click on that, click on PC1, and then click on Switch 1. And now they are connected. Then I'll do the same to connect PC2 to Switch 1. Now here's a trick to speed things up. Hold down the Control key on your keyboard and click on the lightning bolt. Then I'll connect Switch 1 to R1. But notice after connecting them, I don't have to click the lightning bolt again. It is still selected because I held down Control while clicking it. So I'll connect R1 to Firewall 1, Firewall 1 to the Internet to R2, R2 to Firewall 2, Firewall 2 to Switch 2, Switch 2 to Server 1, Switch 2 to Server 2, and finally the attacker to the Internet. Now they're all connected, so I'll click Cancel here, since I don't need to do any more connections. Okay, we're done with the lab instructions. We have successfully recreated the network diagram as shown in the lecture videos. Most days of the course will include a Packet Tracer lab, so you can practice configuring Cisco routers and switches. Ideally, you should try to complete the lab on your own in Packet Tracer after watching the lecture video. Then, you can check my lab video after to confirm your solutions. However, if you're having trouble doing the practice labs on your own, feel free to watch each lab video before actually trying the lab in Packet Tracer. That's not a problem. The important thing is that you get hands-on practice with Cisco routers and switches to deepen your understanding of the concepts we cover in the course, and also to prepare for the exam. Okay, that's all for this video. I hope it was helpful. Thanks for watching.
You're welcome.
Before finishing this video, let me thank my
想当 AI 人工智慧工程师吗？无论你是想学习大数据分析、Web 后端开发，或想踏入火红的 AI 人工智慧领域，来联成电脑学。
Welcome to my complete CCNA, Cisco Certified Network Associate course. This is Jeremy's IT Lab. This course aims to be a complete course for the CCNA, including extra knowledge of about some different kinds of devices you'll photo. This is the front of a switch, but that's for later in the course. Take a look at this photo. This is the front of a switch. Notice the 24 interfaces, also known as ports. Remember, as we learned in the last lecture, one characteristic of switches is that they tend to have lots of interfaces to connect end hosts like PCs and servers to. Now let's look at those words above the interfaces. I'll zoom in. 10/100/1000 base T ports, 1 to 24. Ports are auto MDIX. Unless you've already studied this stuff, you probably have no idea what that means. Don't worry. By the end of this video, you'll understand all of this and more. Now let's focus on the interfaces themselves. I'll zoom in again. Do you recognize this shape?
Yeah.
If your computer is connected to a wired network, it's surely using a port like this to connect to the network. These are called RJ45 ports. RJ stands for registered jack, by the way. Let's look at the RJ45 connector at the end of a cable. I'm sure you've seen one before. These are all cables with RJ45 connectors. As you can see, there are some variations in design and color, but all of these connectors would fit into the ports we saw in the previous slide. The RJ45 connector is used on the end of a copper Ethernet cable. There are Ethernet cables which do not use copper wiring as well, but we'll get to that later. First of all, though, what is Ethernet? Ethernet is a collection of network protocols and standards, rather than just a single protocol. So really, Ethernet isn't one single thing, making it difficult to define exactly what it is.
For the purpose of this lesson, we will focus on types of cabling as defined by Ethernet standards. As said above, there are many standards included in Ethernet, but the focus of this lesson is interfaces and cables, so that's what we'll focus on. However, we will learn other aspects of Ethernet in future lessons. Now, before we learn about Ethernet cable standards, I want to give a brief explanation of why we need network protocols and standards. If two people are talking to each other, and one only speaks English, and the other only speaks Japanese, there's not going to be much or any communication between them. What they need is some agreed-upon system of communicating, like a common language between them. Network protocols serve that purpose for network devices. That's why standards like Ethernet exist. Since we're talking about interfaces and cables in this video, here's a more relevant example. If you're trying to connect to, for example, a network switch, but the maker of the cable and the maker of the switch haven't agreed upon the same to connect. Since we're talking about interfaces and cables in this video, here's a more relevant example. If you're trying to connect to, for example, a network switch, but the maker of the cable and the maker of the switch haven't agreed upon the size and shape of the connector and port, you won't be able to connect them. That's why there are industry standards that all vendors follow, both in terms of physical standards like connectors and cables, as well as logical standards like IP, the Internet Protocol. Now, connections between devices in a network operate at a set speed. These speeds are measured in bits per second. What is a bit? Well, it's a value represented by either a 0 or a 1. This binary code is how computers work. YouTube, this video, your operating system, all of it is
Wait, I want to replace someone.
just a series of zeros and ones, which your computer interprets. When communicating across a copper network cable, a variation in the electrical signal is interpreted by the receiving device as a 0 or a 1. So that's a bit. What's a byte? Here we have a series of 8 bits. 8 bits equal to 1 byte. Now, speed is measured in bits per second. Imagine a byte, 8 bits, of data being sent along a wire. It reaches the neighboring device 1 bit at a time like this. It doesn't operate 1 byte at a time like this. So remember, speed is measured in bits per second. For example, kilobits per second, megabits per second, gigabits per second, and not bytes per second. Data on a hard drive, for example, is measured in bytes, however. So remember, a gigabyte is actually 8 times larger than a gigabit. So let's review some of these measurements. 1 kilobit is equal to 1,000 bits. Add 3 zeros to that, bit, or once.
Yeah, I know.
Speeds are always increasing, however, so terabits per second speeds may be commonplace soon enough. Now, there are further units. Here's a snapshot from Wikipedia. Beyond terabits, there are petabits, exabits, zetabits, yottabits, and more. Don't worry about memorizing all of these, though. You're not going to see network speeds like these anytime soon. Okay, finally, let's talk about some Ethernet standards. These are all defined in the IEEE 802.3 standard. The IEEE is the Institute of Electrical 3. Let's take a look. So, here's a table of some IEEE standards for copper Ethernet cables. We'll also take a look at fiber optic cables later in this lesson, but I decided to split them up. We have one for each of the common network cable speeds: 10 megabits per second, 100 megabits per second, 1 gigabit per second, and 10 gigabits per second. The next column lists the common names. These are the names we usually use when talking about different network interfaces, cables, and their speeds, for example in a work environment. The next column lists the official IEEE standard in which they are defined. You would probably never use these names when talking with other network engineers about a cable, but you should be familiar with them. This next column lists informal standard names given to each standard: 10 base T, 100 base T, 1000 base T, and 10G base T. The numbers obviously refer to their speeds, but how about base and T? Well, base refers to baseband signaling. That's totally out of the scope of the CCNA, but just so you know the meaning. T refers to twisted pair cabling, and we'll talk about that very soon. Finally, the maximum cable Ethernet, for performance and technical reasons. So that's a lot of information, but I recommend you memorize these standards. It may seem difficult, but with the flashcards in the description, it's actually quite easy. So don't forget to download and use the flashcards in the description, and also make your own if you want. Okay, now let's continue and look in more detail at the physical cables themselves. The copper cables used in Ethernet standards are UTP cables. UTP stands for unshielded, twisted pair. Unshielded means that the wires have no metallic shield, which can make them vulnerable to electrical interference. The twisted pair part is easy to understand from this photo. As you can see, there are 4 pairs of cables twisted together. The twist actually helps protect against electromagnetic interference, or EMI. So there are 4 pairs of wires twisted together. That makes 8 wires in total. Let's take a look at one of those RJ45 connectors we saw earlier. If you count the number of pins here, you'll find that there are 8 pins, perfect for the number of wires we saw in the last photo. However, not all of the Ethernet standards we saw before actually use all 8 wires. 10 base T and 100 base T, also known as Ethernet and fast Ethernet cables, use 2 pairs or 4 wires. 1000 base T and 10G base T, however, use all 4 pairs or 8 wires. Let's focus on the first two for now, 10 base T and 100 base T.
Help me, help!
So let's say we're connecting a PC to a switch with a fast Ethernet connection. These numbers represent the pins on the RJ45 on the PC's network interface card and the switch's interface. There are 8, but we will only use 4 or 2 pairs, since this is a fast Ethernet or 100 base T connection. The first pair is at pin positions 1 and 2, and will connect to pins at positions 1 and 2 on the switch's network interface. Although in this diagram the wires look straight, remember that in a UTP cable, the pairs are twisted together. It's pins 1 and 2 to transmit data to the switch, which we can write as TX. Because the PC is transmitting data on pins 1 and 2, the switch cannot transmit data on those pins. It has to receive data, which we can write as RX on server, transmits data on pins 1 and 2, and the interfaces on a switch receive data on pins 1 and 2. Now, the next pair that is used in a 10 base T or 100 base T cable is not 3 and 4. It's 3 and 6. And of course, the function of each pin is opposite of the pair on pins 1 and 2. On the switch, pins 3 and 6, this allows for what's called full duplex transmission, and no problems like collisions will occur at the same time, and the PC usually connects to a switch. A switch usually connects to a router. PC to a router. Data at the, just as a PC usually connects to a switch usually connects to a router. 3 and 6. Now, which pairs on which side are used to transmit, and which are used to receive? Well, we know how a switch functions from the last slide. Pins 1 and 2 receive data, and pins 3 and 6 transmit data. How about a router? Well, the network interfaces on a router transmit and receive data on the same pairs that a PC's network interface card does. A router transmits data on pins 1 and 2, and receives data on pins 3 and 6. Again, Ethernet uses full duplex transmission, so the two devices can send data at the same time and receive data on pins 3 and 6. This is the same as a PC. Once again, switches are the opposite. They receive data on pins 1 and 2, and transmit data on pins 5. When connecting a PC to a switch, or a router to a switch, this works fine. Because they transmit and receive on opposite pin pairs, a regular cable like this works well. This kind of cable, by the way, is called a straight-through cable. Remember, a copper Ethernet cable has 2 RJ45 connectors, one on each end. This kind of a cable is called a straight-through cable because pin 1 on one end connects straight through to pin 1 on the other end. Pin 2 connects to pin 2, pin 3 connects to pin 3, and if we want to connect a router to another. Now, in networks, we don't always connect PC to switch, switch to router. What if we want to connect a router to another router? Or maybe a switch to another switch? Or maybe connect 2 PCs together? Now I've replaced the switch on the right with another router. What will happen if the router on the left sends data to the router on the right? Well, it's simply not going to work. The right router isn't prepared to receive data on pins 1 and 2 of its interface, so communication between the two routers just doesn't happen. So how can we successfully connect 2 routers together? Or perhaps 2 switches or 2 PCs? The same thing applies to connecting a PC directly to a router also, because they both transmit data on pins 1 and 2, and receive data on pins 3 and 6. Let's take a look. I've replaced the 2 routers with 2 switches, just to demonstrate that the same thing applies. If the switch on the left tries to transmit cable, a straight-through cable connects pin 1 to pin 1. The answer to this problem is a different type of cable. A straight-through cable connects pin 1 to pin 1, pin 2 to pin 2, pin 3 to pin 3, etc. But there's another type of cable, called a crossover cable. In a crossover cable, a pin on one end of the cable doesn't connect straight to the same pin on the other end. Essentially, the pairs are reversed on each end. So, pin 1 on one side connects to pin 3 on the other side, and pin 3 and pin 6 on the crossover cables can send data to each other with no problems. Here's another example. Again, the network interface card on a PC and the network interfaces on a router both transmit data on pins 1 and 2 and receive data on pins 3 and 6. However, if you connect them together with a crossover cable, they will be able to exchange data with no issue. Receive data. Routers transmit data on pins 1 and 2 and receive data on pins 3 and 6. Firewalls are the same as routers. They transmit data on pins 1 and 2 and receive data on pins 3 and 6. PCs also transmit data on pins 1 and 2 and receive data on pins 3 and 6. Switches are the only different one of the group. Switches transmit data on pins 3 and 6 and receive data on pins 1 and 2. Try to remember these. The flashcards included in the description will help and receive data. Switches are the only different one of the group. Switches transmit data on pins 3 and 6 and receive data on pins 1 and 2. Try to remember these. The flashcards included in the description will help with this, so I recommend that you use them. While all of that is important information to know, and can cause issues in networks even in the modern day, the truth is that most modern networking devices have evolved beyond having to worry about straight-through or crossover cables. That's because newer networking devices include a feature called Auto MDIX. Previously, if two switches were connected with a straight-through cable like this, they would be unable to communicate. However, Auto MDIX allows devices to automatically detect which pins their neighbor is transmitting data on, and then adjust which pins they use to transmit and receive data. They can then exchange data normally. So, unless you're working with network equipment that is quite old, you don't really have to worry about straight-through and crossover cables. But this is good information to be aware of, and it's also good to learn about the concept of Auto MDIX, both for the exam and for real-world networking. So, we've talked a lot about 10 base T and 100 base T, but what about the higher speed copper Ethernet cables? Remember, I said before that for gigabit Ethernet and 10 gigabit Ethernet, all 8 wires are used. The last two pairs are 4 and 5, and 7 and 8. Again, there will be flashcards to help you remember these details. It may seem like a lot to memorize, but if you use 7 and 8 are used. The last two pairs are... It may seem like a lot to memorize, but if you use the flashcards properly, it's amazing how easy it is to remember all of these things. Now, here's another big difference between 1000 base T and 10G base T, and 10 base T and 100 base T. In addition to using all 4 pairs of wires, in 1000 base T and 10G base T, each pair is bidirectional, meaning each pair isn't dedicated specifically to transmitting data or receiving data. In addition to using all 4 pairs of wires, in 1000 base T and 10G base T, each pair is bidirectional, meaning each pair isn't dedicated specifically to transmitting data or receiving data. This is part of the reason that they can operate at much faster speeds. Okay, we've covered a lot about connections using copper UTP cables, but there is a newer technology that is superior in many ways. For example, copper UTP wiring can be used for up to 100 meters. That's usually plenty within a LAN, but how about for larger networks? Look at this Cisco switch here. Here it has 24 ports for RJ45 connectors. These are the ports you would connect a copper UTP cable to. But what about these 4 interfaces? Take a look at this Cisco router also. It only has 4 RJ45 ports. The rest of them look like those other 4 ports on the switch. In these interfaces, you insert one of these. It's called an SFP transceiver. SFP means small form factor pluggable. So you insert one of these into the device, but still things aren't complete. What kind of cable connects to one of these? You connect one of these cables. This is a fiber optic cable. Rather than an electrical signal over copper wiring, these cables send light over glass fibers. Notice that there are 2 connectors on each end. That's because you need one connector to transmit data and one to receive data on each end.
And we're back in third quarter planning. Adams is quarterbacking this.
The copper UTP cables use separate wires within the cable to transmit and receive data. The fiber optic cables instead use separate cables to transmit and receive like this. Now let's examine the structure of the cable itself. There are 4 numbered parts in this diagram, from the center to the outer layer.
Core.
Number 1 is the fiberglass core itself. Light is transmitted down this core to transmit data from one device to another. Number 2 is cladding that reflects light. Number 3...
The cladding reflection index should be lower than the core. Refraction index compared to the core, it should be lower if I'm not mistaken. Core is also greater, so the cladding should be lower.
3 is a...
because of the total internal reflection will only happen if a light travel from a higher refractive index to the lower
protective buffer, which protects the fiberglass from breaking. And number 4 is the outer jacket of the cable. Now, there are a couple main types of fiber optic cables: single mode fiber and multi-mode fiber. Let's check out their characteristics and differences. These are 2 examples of multi-mode fiber cables. The center represents the fiberglass core, and the blue represents the reflective cladding that reflects light down the cable. The center represents the fiberglass core, and the blue represents the reflective cladding that reflects light down the cable. In multi-mode fiber cables, the core, the actual glass fiber, is wider than single-mode fiber. This wider core allows multiple angles, known as modes, of light waves to enter the fiberglass core, as you can see in these 2 diagrams. Notice the red and black lines representing light waves traveling down the fiberglass core, reflecting off the cladding at different angles. Multi-mode fiber allows longer cables than UTP, which are limited to 100 meters, but still shorter than single-mode fiber.
Allows longer but shorter cables than single mode. Okay.
Which we will look at next. Multi-mode fiber cables are cheaper than single-mode fiber, and this is because they use cheaper transmitters, which are often LED-based.
Multi-mode is cheaper than single mode because of cheaper LED-based transmitter. Okay.
This is an example of a single-mode fiber cable. Again, the center represents the fiberglass core, and the blue represents the reflective cladding. The core diameter of a single-mode fiber cable is narrower than a multi-mode fiber, meaning the glass fiber is thinner. You can notice this in the diagram here, compared to the multi-mode fiber diagrams. Light enters at a single angle, known as a mode, from a laser-based transmitter. Notice in the diagram that the light wave travels straight down the core of the cable. Single-mode fiber allows longer cable lengths than both UTP and multi-mode fiber cables. And single-mode fiber cables are more expensive than multi-mode fiber cables, due to the more expensive laser-based transmitters used. Okay, now let's look at some standards for fiber optic cables like we did with UTP cables. Here's another chart like the one we looked at for copper UTP cable standards, this time for fiber optic cables. First up is a standard for 1 gigabit Ethernet over fiber, known as 1000 base LX. It is defined in the 802.3Z, or Z, standard. This standard can be used over single-mode or multi-mode fiber cables. And you can see the difference in the maximum cable lengths, 550 meters for multi-mode fiber, and 5 kilometers or 5,000 meters for single-mode fiber. Next up is 10G base SR, defined in the 802.3 AE standard, which operates at 10 gigabits per second. It uses multi-mode fiber and can support cable lengths up to 400 meters. Next is 10G base LR, also defined in the 802.3 AE standard, again operating at 10 gigabits per second. 10G base LR, however, uses single-mode fiber, and cable lengths can be up to 10 kilometers. Finally, 10G base ER, also part of the 802.3 AE standard, and operating at 10 gigabits per second. It supports cable lengths even longer than 10G base LR, with distances up to 30 kilometers possible. I will include flashcards to help you remember these standards, but however, with the flashcards it's quite easy to remember these little facts, so I recommend not deleting those flashcards, but that's your choice of course. With the flashcards it's quite easy to remember these little facts, so I recommend not deleting those flashcards, but that's your choice of course. Finally, let's review by comparing UTP optic cables. UTP cables can be vulnerable to electromagnetic interference. 5 ports to which UTP cables connect are cheaper than the SF side of the cable, optic, which could possibly be detected and used to copy data, posing a possible security risk. Now let's look at 5 than UTP cables. Their SFP ports are more expensive than RJ45 ports, and longer distances than UTP cables. Their SFP ports are more expensive than RJ45 ports, and single-mode fiber ports are more expensive than multi-mode. They do not emit any signal outside of the cable. To remind you of the supplementary materials for the video that will help you remember what you learned. Like in the last video, cards to help you review the information using PAC quiz questions.
Okay.
You connect 2 old routers together with a UTP cable. However, data is not successfully sent and received between them. What could be the problem?
Because the 1, 2, and 3, 6. Yeah, it's not cross because it's used straight through cable.
Or C, they are operating in auto MDIX mode. A, their cable is not the issue. 2, on the other routers, own operation might not have across 50 meters apart.
The company, they want to keep costs down. What kind of cable should they use? Multi-mode fiber.
They want your answer. Let's check. So A, meter fiber. Your company wants what kind of cable should they use? Offices that are about 3 kilometers.
3 kilometers. They want to keep costs down. If possible, what kind of cable should they use? Single mode, but with standard of EX.
Part UTP. Pause the video to think about your answer. Let's check. So A, not support many single mode options.
Okay.
A switch has the following indication over its network interfaces. What would happen if you connected to an identical switch with a straight-through cable? Feed.
Normally.
Not operate.
Normally.
The answer is A. They would operate normally. Enabled. Wouldn't operate. Sorry, auto. They would be unable to operate normally. Correct answer. Switch, which is in a wiring cabinet.
You're gonna many and host to a switch which is in wiring cabinet. What kind of cable? UTP.
Think about your answer. Let's check the answer. Switches do not have or include have many RJ to connect.
Okay, thanks. Let's go review it. Where's the Anki? Interface and card. Study now. What is the speed of Ethernet connection? It's 10 megabits per second. Good. LR, long range, maximum cable length. Wait. Long range is 5 kilometers. 10 kilometers hard. In fast Ethernet, router receive data on pin. Router. Fast Ethernet is 10 megabits. So receive data on pin 3 and 6. Good. Firewall receive data on pin receive 3 and 6. How many pairs? 10 base T. 2 pairs, 4 cables. Yep. 100 base T. 802.3 U. It's hard. 802.3. Just 802.3. No I. What is the speed of 10 gig Ethernet? 10 gigabits per second, of course. Ethernet defined IEEE 802.3. What are the two kind of fiber optic? Single mode and multi-mode. In fast Ethernet, PC receive data on pins 3 and 6. Single mode or multi-mode? Multi-mode. 10 gigabits per second, 802.3 AN hard. How many pairs of wires? 10 gigabits. 4 pairs, 8 wires are connected to fiber optic cables are connected to SFP. Yeah, good. Emits a faint signal, UTP. What kind of UTP should be used to connect two routers together straight through? Oh, disabled, sorry, it's my bad, hard. 802.3 AB hard. Why are the wire pairs twisted together to protect from electromagnetic interference? Vulnerable UTP. What is the speed of fast Ethernet? It's 100 megabits per second. Connection allows both devices to send and receive at the same time. Full duplex connection, which allows longer cable, single mode or multi-mode, single mode. How many bits are in 1 megabit? 1 million. Multi-mode have multi-mode wider. How many bits are in 1 terabit? I don't know. 1000 trillion. How to say 1000 trillion in English? 1000 billion. Oh, trillion is just trillion. Okay, good. How many bits are 1000? How many pairs of wires are used in 1000 base T? 4 pairs, 8 wires. 2 pairs, 4 wires. Firewall transmit data on which pin? Transmit data 1 and 2. If auto MDIX is disabled, what kind of device should be connected to switch together? Auto MDX crossover cable. Network speeds are measured in bits per second. Yep. If disabled, can use to connect a PC and switch. PC and switch, just a straight through cable. Okay. ER extra range 50 kilometer, I think. Oh, 30 hard. What is the speed of gigabit Ethernet? 1 gigabit per second. Good. Which 4 pins are used in 4 pair pins are used in 1, 2, 3, 6, 4, 5, 7, 8. 3, 6, 4, 5, 7, 8. Yeah, good. How many bits are in 1 byte? 8. SR short range 1 kilometer. 400 meter? Oh, no, it's my bad. SR were defined IEEE 802.3 AE. Yeah, good. What can we connect? Router and switch straight through. LX maximum cable length. LX 400. So a bit hard. What is the name of connector on the end of Ethernet UTP RJ45? What is the measurement of UTP 100 meters? Which two pins are used? 1, 2 and 3, 6. What is the name of which allows a device to automatically adjust auto MDIX? What kind of cable connect a pin pair on one end of UTP to the opposite? Crossover cable. How many bits are in 1 gigabit? 1 million. Billion. 1 miliar, 1 billion. Long range, maximum cable. Wait, let me think. Long range. Long range. 1 kilometer. 10 kilometer. Hard. What kind of cable connects a pair pin on one and at the same? What kind of cable connects a pin pair on one and same pair straight through? Good. Allow multi-mode. Find a switch, transmit data on pin 1 and 2. No. 3 and 6. Light travels straight through the inner core at the single mode. What does UTP? Unshielded twisted pair. LX 802.3 AI Z hard. How many pins are in RJ45 connector? 8. IEEE 100 megabits per second Ethernet 802.U. Gain. In a fast Ethernet connection, a switch receives data on which pin? Fast Ethernet switch receive data in 1 and 2. IEEE standard 10 base T 802.3i 10 gigabit 802.3 AN. Okay. If auto MDIX is disabled, what kind of UTP cable should be used to connect two routers to get a crossover? In fast Ethernet, router transmit data on pin 1 and 2. Good. And PC transmit data 1 and 2. IEEE standard 802.U. Again. 1 gigabit 802.AN. AB. Again. 10 megabits per second 802.3i. 10 gigabits per second 802.3 U. Again 100 megabits 100 U 802.3 U. 10 megabits 802.3i. 1 gigabit 802.3 AB. Good. 10 gigabit 802.3 AN. Good. 10 megabits 802.3i. ER. Maximum cable length. Extra range. So I would say it's 4 kilometers. No. 10 kilometers. 30. Again. 100 megabits per second. 802.3 U. Good. Speed Ethernet on 10 megabits per second. Short range, maximum cable length 550 meter for multi-mode and 5 kilometer for single mode. No, that's almost. No, that's not a SR. Short range is short range 1 kilometer 400 meter hard. Extra range 30 kilometers. Good. LX 550 meter for multi-mode, 5 kilometer for single mode. Good. There are the two main kind of fiber optic cable, multi-mode and single mode. Good. Fast Ethernet fiber receive data on pin, receive 3 and 6. Ethernet 802.3 UTP In Fast Ethernet, a router receives data on which pins? Fast Ethernet router receive data on pin 3 and 6. How many pairs? 10 base T. 10 base T, 2 pairs, 4 wires. Good. Fast Ethernet 100 megabits per second. 10 gigabit, 10 gigabit per second. Longer cable, single mode. LX was defined. LX 802.3Z. Yep. Long range, maximum cable length. Long range, not ER, but long range, 10 kilometer. Yep, good. Fast Ethernet PC receive data on pin 3 and 6. How many bits are in 1 megabits? 1 million. Fiber optic cables are connected to SFP. Which one is cheaper? Multimode. Connection log both device to send receiver at the same full duplex. Cables are vulnerable to EMI, electromagnetic interference, UTP. Good. Multimode cables have a multimode wider. How many pairs of wires are used in a 10 G base T cable? 4 pairs, 8 wires. Why are the wire pairs and UTP twisted together? To protect from electromagnetic interference. In a fast Ethernet connection, a firewall transmits data on which pin? Transmit 1 and 2. Network speed are measured in bits per second. How many bits are in 1 terabit? 1 trillion. What is the speed of gigabit Ethernet? 1 gigabits per second, of course. How many bits are in 1 kilobit? 1000. How many pairs used in 1000 base? 4 pairs, 8 wires. SR, LR, ER, 802.3 AE. Good. How many pairs are used in 100 base? 2 pairs, 4 wires. Good. Which 4 pairs are used in 1000? 1, 2, 3, 6, 4, 5, 7, 8. 1, 2, 3, 6, 4, 5, 8, 7, 8. Yeah, good. What is the name of feature that allow Auto MDIX? How many bits are in 1.8? If auto should 2 switches together crossover. Short range, 400 meter. Good. Which 2 pin pairs are used in 10? Oh, 1, 2, 3, 6. Good. If auto MDX PC and switch straight through. Auto MDX is disabled. UTP router and switch straight through. What is the maximum range of Ethernet UTP? 100 meter. In a fast Ethernet connection, a switch transmits data on which pin? It's in 3.6. In the fiber light travel through fiber at a single mode. What kind of cable connects a pin pair on one end of UTP cable to the opposite pair of the other end? Which kind of cable connects a pin pair on one end of the end? What kind of cable connect a pin pair on one end to the opposite pair on the other? RJ45, you mean? Connects a pin on one end to the opposite pair. Oh, okay. Again. How many pins are there? 8. Good. What kind of cable connects a pin pair on one end to the opposite pair? Crossover. In a fast Ethernet connection, a switch receives data on pin. Receive data. Switch 1 and 2. What's the name of Ethernet on connector RJ45? Good. How many bits? 1 gigabit? 1 billion. 1 miliar. Multimode. What kind of cable connects a pin pair on one end, a crossover, a same pair on the other end, straight through? If auto MDIX disabled, to router crossover. What does UTP stands for? Unshielded twisted pair. Good. 1 Gbps, 1.802.3 AB. Good. In a fast system, PC transmit data on between 1 and 2. 100 megabits 802.3 E. No U. Again. 10 megabits per second Ethernet 802.3 I. Good. 100 megabits per second 802.3 U. Good. In a fast system connection, a router transmit data on which pair? Router transmit data on 1 and 2. Good. IEEE standard for 10 gigabits per second Ethernet. 10 gigabits per second Ethernet. 802.3 10 AN. LX maximum cable length 550 meter for multi-mode, 5 kilometer for single mode. Good. Extra range cable length 30 kilometers. LX was defined L2.3Z. Long range maximum cable length 10 kilometers. Good. Short range maximum cable length 400 meter. We're gonna one and opposite pair crossover. Good. IEEE standard 100 megabits per second 802.3 U. Good. Phew. Masak nasi dulu ya guys.
Thank you for watching.
Masak nasi dulu buat berbuka.
That's all for this video. If you want to show your support, please subscribe to the channel, like the video, leave a comment.
As a student, you're probably getting PDFs all the time, right? A teacher might assign you a bunch of PDFs that you have to read by next week, and you have 6 different classes and they're all dumping PDFs on you. For a lot of people, listening is how they actually prefer to learn.
Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA 200-301.
Trace.
If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Let's get started. In this lab, you will use what you learned in Day 2's lecture video to connect these network devices together.
Learning CCNA Day 2. For practice, assume that AutoMDIX is disabled or not supported on the devices. Use the appropriate type of cable. Okay. How to practice here. R1, R2. Wait, what? Oh, it's like this. Let's move it here.
You can select various types of connections from the bottom left here. We'll be using copper straight through, copper crossover, and fiber connections. Note that Packet Tracer doesn't differentiate between single mode and multi-mode fiber, but connections. Note that Packet Tracer doesn't differentiate between single mode and multi-mode fiber, but try to think about which type would be appropriate when you use a fiber connection. So, I'll start here in the bottom left.
Oh, is this a solution? Oh, switch to PC. Switch 4 to PC, just copper straight through. Fast Ethernet, of course. Copper straight through. Fast Ethernet, Fast Ethernet. Switch 2 and switch 1 and switch 3. Copper crossover, Fast Ethernet 2, Fast Ethernet 0, copper crossover, Fast Ethernet 2, Fast Ethernet 0. Oh wait, delete. Ethernet 0. Okay, whatever. That worked. Router to switch. Oh wait, switch 1 to switch 2. Copper crossover. Fast Ethernet 1, Fast Ethernet 1. Router 2 to switch 1. Copper straight 2. Fast Ethernet. Copper straight 2. Switch 2, right? R1, R2, distance 50 meter, crossover. Okay, and then switch 7 PC, switch PC straight to true. Switch and server, so straight through. This one should be, yeah, crossover. Yeah, good. Crossover. Switch to switch. Copper crossover. Also copper crossover. Oh wait. Switch 5, switch 6, also crossover. And then router to switch should be straight through. And then router 3 and 4 should be fiber because it has a gigabit Ethernet. $3 km. You have gigabit Ethernet. Why don't you told me? Okay.
First, the PII uppercase 6 is 1 to the network interrupt. The transmit pins will be connected to the device. Switch 1 to switch 2. Next, let's connect these switches to the routers. So let's connect switch 10, switch 6 to R4. Now it's time to connect the router. Take care of copper cabling cable. The fiber optic for this connection. We would use in Packet Tracer, and R4 are separated by fiber. Devices are now. If you want to show your support, please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. I accept donations via cryptocurrency or Patreon via the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. Welcome to my complete CCNA Cisco Certified Network Associate course. This is Jeremy's IT Lab. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. Stay tuned till the end of the video for the quiz to test your knowledge of the material in this video. Also, remember to download and use the Anki flashcards with the link in the description. Let's get started. This third lesson is about two networking models. The first is the OSI model, and the second is the TCP/IP suite. Note that the TCP/IP suite is a networking model too, but it's usually referred to as the TCP/IP suite or just TCP/IP. Unless you're familiar with networking, you probably haven't heard of the OSI model. However, you probably have heard of TCP/IP, or at least the second part of that name, IP, the Internet Protocol. For example, you've probably heard of an IP address before. So, what is a networking model? Well, networking models categorize and provide a structure of Ethernet. A networking protocol is a set of rules defining how network devices and software should work, including how they should work together. So, protocols refer to logical rules about how devices should communicate, not physical standards. So, you could visualize it like this. The different colors represent different categories of protocols and standards. These protocols and standards could define something like the structure and usage of IP addresses, or maybe physical details like electrical voltage used on copper cables when transmitting data. Let's talk about the OSI model first, and then we'll look at the TCP/IP suite after. So, what if there were no standard networking models and protocols? Here's a few Dell PCs, and a few iMacs. If Dell and Apple each made their own network, and these iMacs would be able to communicate with each other, but because the Dells and iMacs would speak a different language than each other, with a different set of rules about how to communicate, the Dells wouldn't be able to communicate with the iMacs in various countries to be able to communicate with each other. The OSI model is one attempt at standardizing network communications. Although it isn't actually in use today, it has had a big impact on how network engineers think about networking, and we still refer to it today. OSI stands for Open Systems Interconnection Model. Open means that it is an open standard, not
presentation, session, transport network data link physical, application presentation session, data link, transport, application presentation session, transport data link, transport network data link physical.
Not a proprietary model, different functions in a network. It was created by the International Organization for Standardization, the ISO, for example, out in the data to make the network interacts with software applications that have some communication component, such as your web browser, whether that's Brave, Firefox, Chrome, or whatever. For example, for Cisco.com, indicating that HTTPS in itself, TPS, synchronizing communication. Let me explain communicate with each other. The system on the right, it on. Data reaches the information is removed are examples of adjacent layer interaction. Systems allows the application layer to its functions of identifying communication partners. The presentation. It needs to be translated to a different format to be sent over the network. The presentation layer's job is to translate between application and network formats. One example of a function of the presentation layer is encryption of data as it is sent, so that only the intended recipient can read it. And of course, decryption as it is received. The presentation layer also translates between different application layer formats to ensure that the data is in a format the receiving host can understand. To summarize, the presentation layer translates data to the appropriate format. That's all you really need to know about the presentation layer. To summarize, the presentation layer translates data to the appropriate format. That's all you really need to know about the presentation layer. Layer 5 of the OSI models. It establishes, manages, and terminates connections between the local application, for example your web browser, and the remote application, for example YouTube. YouTube servers are being used by countless people at every moment. Presentation and session. That is the job of application developers. Application developers work with the top layers of the OSI model to connect their applications over networks. So, data prepared at the top, after the top transport layer, adds a header in front of the data, like this. So, let's look into the transport layer a little bit. Layer 4 of the OSI model is the transport layer. It's large pieces of data into smaller segments, which can be easily sent over the network and are less likely to cause transmission problems if errors occur. For example, if data wasn't segmented and you were trying to watch a video, if an error occurred that prevented the video from reaching your computer, you wouldn't be able to watch the video at all. Big problem. Transport layer provides host-to-host communication, or header is added on. Or header will be added on to each segment. And hosts on different networks. For example, outside of the local area network, or in the form of IP addresses, something you've probably heard of before. Layer 3 also provides path selection between source and destination. Often there are many possible paths which data can take to reach its destination, especially over a huge network like the internet. Layer 3 provides the means of selecting the best path. Routers operate at Layer 3. That's because router data is prepared by the devices. Let's review the encapsulation process again. Data is prepared is called and destination is to header, and next the packet is further encapsulated at Layer 2, this time with both a Layer 2 header and a Layer 2 trailer.
Trailer is used for error correction, if I'm not mistaken.
Layer 2 of the OSI model is the data link layer. The data link layer provides node-to-node connectivity and data transfer. For example, direct connections between a PC and a switch, or a switch and a router, or a router and a router. Because Layer 2 is adjacent to Layer 1, the physical layer, it also defines how data is formatted for transmission over a physical medium, like copper UTP cables. Like Layer 3, Layer 2 also uses an addressing system. However, it is separate and different from Layer 3 address. Layer 2 address, to determine what's prepared by the applicator, is added to a Layer 2 header, and a Layer 2 trailer are added to the packet. Header and Layer 2 trailer is called the combination of data, Layer 4 header, Layer 3 header, Layer 2 header, and Layer 2 trailer is called a frame. Now, the data is not further encapsulated at Layer 1. This frame is then sent over the connection, whether it's electrical signals over a wire, or wireless signals in the case of Wi-Fi, to the neighboring system. Let's look at Layer 1 of the OSI model a bit before moving on. Layer 1 of the OSI model devices. Video, physical connectors, cable specifications, etc. signals for wireless connections like Wi-Fi. As I mentioned before, all of the information in Day 2's video, such as cables and pin layouts, is related to the physical layer of the local device over this cable, let D in. Then the Layer 2 header and trailer are removed, leaving the Layer 3 packet. The Layer 3 header is removed, leaving the Layer 4 segment. Finally, the Layer 4 header is removed, and we are left with the original data prepared by the upper layers of the original device. That's the process of de-encapsulation. It wants to send data. It's called a data link layer that is used to refer to all of these. These are all called protocol data units, or PDUs. For example, segment is the term for a Layer 4 PDU, packet is the term for a Layer 3 PDU, etc. By the way, at Layer 1, the physical layer, the name for the PDU is bit, referring to the bits being transferred on the wire. So, the name for the PDU is bit, referring to the bits being transferred on the wire. The flashcards included in the description should be a big help, but here are a couple acronyms too. I don't use acronyms to remember things myself, but many people like them. All people seem to need data processing. Here's another one from Layer 1.
All people seems to need data processing. Application, presentation, session, transport, network, data link, physical layer.
To Layer 7. Good ones, please post them in the comment section. Now let's move on from the OSI and set of communications protocols. And in TCP/IP's case, it is used in the internet and other networks. It is known as TCP/IP because those are two of the foundational protocols in the suite. It was developed by the United States Department of Defense through DARPA, which is the Defense Advanced Research Projects Agency. It's in modern networks, not OSI. Note, however, that the OSI model still influences how network engineers think modern networks, not OSI. Note, however, that the OSI model still influences how network engineers think and talk about networks. The OSI model you're familiar with by now. And on the right is... Now let's compare the two. On the left is the OSI model you're familiar with by now. And on the right is the TCP/IP suite's networking model. The application, presentation, and session, combining them into one, actually represents how network engineers tend to think about networks. Use the OSI, think of OSI's Layer 4, the transport layer, not TCP/IP's Layer 4, the network layer of the OSI model maps to the internet layer, equivalent to the problem in the internet layers. This is a chart off of Wikipedia, showing different naming systems used. Don't worry about memorizing all of these, but just keep in mind you might hear different names than the ones I taught you. For example, the link layer might be called the network interface, or network access layer. I actually like this 5-layer model because it combines the top 3 layers that we, network engineers, don't really think about into one. But it keeps the data link and physical layers separate, and I think it's good to think of them as 2 separate layers. Before finishing up this lesson and moving on to the quiz, I want to show you this excellent diagram which I found on Wikipedia. It demonstrates the process of a host, host A, sending data to host B with 2 connected to another. Only the internet and link layer wants to communicate video and audio the transport to host B. These TCP connected to a router, connected to another router, connected to host B. Here is the TCP IP stack on each device. Note that, for forwarding data from host to host, these routers don't need to be aware of the higher layers, so only the internet and link layers are present here. So let's walk through the process. An application host, it is for 3 devices. D encapsulating the packet, other route encapsulation. The header with the application during the duration between protocols can communicate. That's the video quiz. The link in the description. Feature of example of what?
HTTP data sent from wait. Sent from user is displayed via your browser. This is an example of what? Application layer.
A. Encapsulation.
Oh. From YouTube is your web browser. Same layer interaction.
Both YouTube's web server and your web browser are operating at layer 7 using HTTP and de-encapsulation of data between layer of YouTube's web. Ignore the other layer interaction with 3 separate headers.
As in 3 separate headers and 1 trailer. What is the appropriate name for this video? Packet. 3 separate packet.
And we to think about your. Let's check.
What? Frame? Data segment.
Packet refers to the OSI layer 3 PDU. Frame. Let's check.
Okay. My bad.
Packet refers to. The answer is C. Frame. 2 headers. Segment refers to the OSI layer 4 PDU. It would have 1 header. The layer 4 header, and no track before being encapsulated. It would have an OSI layer 2 PDU. It has 3 headers, so C of the OSI and physical. Into the role of a network engineer. A. Data link.
OSI 7 layer. Physical.
C. Network only. Or D. Application, presentation, and session. A. Very relevant support, network, data link, and physical is missing. Is very relevant. Application development. Transport. The link layer
is equivalent to what layer or layers of the OSI 7 module? Data link and physical layer.
Transport D. Data link and physical. The answer is the TCP. Data link and physical. And the OSI incorrect. B. Functions of the data link and physical layer of the OSI model provides host-to-host communication.
Host-to-host communication with OSI. Application. All people. Presentations.
Link. Pause the
host-to-host communication.
Video to think about your
application.
Answer.
Transport.
The answer is C. Transport.
Yeah.
Provide C. Transport is the correct answer. Host to B. Communication. Answer is C. Transport. Let's check. Provide. So C. If you want to show your support, please subscribe to the channel.
All people seems to need data processing.
Via crypto.
Let's go. Flashcard. Study now. I don't know. Open system interconnection. 7 layer. Good. Which layer? Node to node connectivity. Node to node connectivity. Data link. Hard. All people. Presentation. Session. Transport. To end host on different. Which layer provides connectivity to end host on different networks. So it's in the application, presentations, session, transport, network. Which layer of the communication partner and synchronized communication? Layer 7 physical, I think. Application hard. Application, presentation, session. Open standard interconnection. Open system hard. Layer 3 PDU. Layer 3 it should be packet. Which network is used in modern network TCP/IP suite? Which layer provides node-to-node connectivity? Node-to-node. Layer 2. Data link. Hard. OSI model application layer. No. Model 2, 7, 6, and 5. Yeah, application 7, 6, and 5. Hard. Routers operate at layers 3. And of layer 1 PDU. Layer 1 PDU bits. OSI model transport layer. TCP/IP. Transport network. All people seems to need. Transport is also transport. Good. OSI transport. Which layer of OSI detects and correct physical layer of correction? Physical layer. Data link hard. OSI data link physical layer. Data link physical layer TCP/IP link layer. Which layer of logical addressing? OSI, so it's in the network. Which layer of path selection between source and destination? Path selection, also network. Application presentation session transport network. TCP/IP link layer. Data link and physical. This layer of translate between data formats. Translate data from application presentation. Application. Process application. Separate switch operate at layer 2. The process of adding additional header and encapsulation. Which layer of host to host communication? OSI application. Wait. Host to host. Transport. Layer 4. 1, 2, 3, 4. Data. Segment hard. Interaction between different on the same device is called between different OSI layers. I don't know. Adjacent layer. Okay. The process of removing header and trailer. De-encapsulation. Application presentation session transport network data link. Which layer of receive data for communication between and host? Segment and reassemble. Application presentation session transport. Presentation session TCP/IP application. Application presentation transport network data link physical. Which layer of the OS establish, manage, and terminates connection between the local and remote application? Terminate connection with local and remote application. Application, so then it's application. Session hard. OSI model TCP/IP internet. Wait. Network. On the same device is called between different OSI layer. Adjacent layer communication. Yeah, okay. Which layer defines physical characteristics of medium use? A physical layer. Which network model defines of TCP/IP? Interact with software application on a computer. Application. Interaction between the same OS and different device is called host to same layer. Yeah, same layer. Layer 2 PDU, it's called frame. OSI model network layer, TCP IP, internet layer. Good. Which layer of OSI identify the communication partner and synchronize communication? Identify communication partners and synchronize communication. Data link. No. Yeah, data link. Application hard. Open system interconnection. Hard. Which layer of OS node to node connectivity? Layer 2, which is data link. Hard. Which layer of OS detects and corrects physical layer error? Data link. Good. TCP IP application layer. Application presentation session. Good. Layer 4 application present. Physical data link. Network transport. So it should be segment. Good. OSI 7. Which layer of the OSI module establish, manage, terminates connection between local and remote application? No. Session. Application sessions. Application presentation session. Transport. Good. Layer 1 PDU bits. Layer 3 PDU segment. Packet. Hard. List of the name OSI in order. Application presentation session. Open system interconnection. Which layer is used in modern TCP IP? Which layer of OSI provides connectivity to end hosts on different networks? Which layer of the OSI model provides connectivity to end hosts on different networks? On different networks, this is the key, so it should be in the network. Node to node connectivity. Layer 2, which is data link. Which layer provides path selection between source and destination? Which layer of OSI model provides path selection between source and destination network? Which layer identify the communication partner and synchronize communication session? Application hard. Data link physical layer. So it should be in the link layer. Routers operate layer 3. Which layer of the network provides local addressing IP address? Local addressing IP address network. Translate data format. So it should be in the application presentation. Session transport network. Transport. Process communication application. Switch over layer 2. Transport layer is also transport layer. Application presentation transport network data link. The process of adding additional headers and trailers to data before is an encapsulation. OSI TCP link layer, data link and physical. Which layer of the communication partner and synchronized communication application? Okay, good. Internet should be the transport network. Which layer of the host to host communication? Host to host, so it's the second layer. Second layer would be the application transport. Which has developed a TCP IP suite? Which layer didn't get a physical layer? The process of removing headers and trailers from data received, removing the encapsulation. Application presentation session transport network data link physical. Application presentation session application. Which layer resemble data between end host should be the segment, which is the transport. Layer 2 PDU is frame. Same device between different layer, adjacent layer. Network, internet. Detect correction, data link or layer 2. On different devices, adjacent layer. Same. Okay, my bad. Hard. Which layer interact with software application? TCP application layer, so application presentation session. Node to node connectivity. Node to node layer 2, which is data link. Okay. Layer 4 PDU. Layer 4 should be segment. Good. Layer 3 PDU. Segment. Packet. Hard. With layer establish, manage, terminate connection between local and remote application. Session. Hard. Open system interconnection. Good. On different device, same layer. Partner and synchronous application. Name of layer 3 PDU is packet. Node to node connectivity, data link or layer 2. So the name of layer 3 PDU it's segment. Segment. Packet. Establish, manage, terminate connection between local and remote application session. Okay, that should be enough for today. Terima kasih semua yang sudah nonton walaupun nggak ada nonton. Jadi catatan progres buat Akmal belajar sendiri mandiri.